Welcome back. We're ready to start talking about our solutions to number 19. So again, they're wanting us to use 5 different equations in order for us to write this. Most of my students typically think of 6 and realize that they don't have enough lines, and that may be something we need to discuss together as a whole class as to which of our function equations can be written together as one. So what we're wanting our students to see is, how do I write the equation of this semicircle from where x is equal to -3 to where x is equal to 3? So if we think about it in terms of a circle, then we have our center at 0, 0 with a radius of 3. So we are then able to get x squared plus y squared equals 9. However, this is f of x, not f of x and g of x. So we just need the portion that is positive, the portion that is above the x-axis. And as well, this is solved for f of x. This is being solved for y. So all of these function equations need to be solved for y. So our students need to take our equation of the circle, subtract the x squared, take the square root, and get that y is equal to plus or minus the square root of 9 minus x squared. And then we have to make the distinction that because we are only looking at the portion above the x-axis, that is the positive version of our solution. This is a great tie-in to make with the equation of a square root and the equation of the circle, and why we need that plus or minus as well. Typically, for the next portion, my students will make the equation of a line and make the equation of a line. Again, using slope-intercept is okay here, but then they have to continue on with the slope in order to get what that y-intercept is. And the same here to continue with the slope to achieve the y-intercept. So using point-slope formula, which they did previously in other practice worksheets, would be a simpler version for them to choose to use here. However, we would love if they could pick up on the fact that that is actually an absolute value equation. That is an absolute value equation that has been translated to the right, reflected down with a slope of -4, giving us our equation that we get here. Now, for students that have not taken Algebra 1 yet, that may be a bit of a gap of information that they do not know yet, depending on how much their middle school teacher did with them when they were writing equations of lines and equations of functions. For our next portion, we have the equation y is equal to x minus 5, which we can get here because our slope is 1. And if you want the y-intercept, then you can continue down to get that y-intercept would be -5. Here, the equation of our line is y is equal to 1. And then we have the equation of our line, y is equal to 1/2 times x minus 9, which can be distributed as well. And again, using the interval notation so that we know that this particular function equation only applies for this portion of our graph. So we have 2 final questions, 20 and 21, that ask us to use this information. So what's great about this activity is that it is easily chunked into smaller pieces, which you can give to different groups and bring back together, or you can give to different members within the group and help them work together. And then as well, at the end, it becomes much more algebraic and allows them to focus on the algebraic side. So the beginning is very geometric and visual and dealing with area and transformations, and then it spirals in the algebra practice that they need. So it's very much an all-encompassing practice activity. So take a moment, look at 20 and 21, and when you're ready to come back and check your solutions with me, press play. We're looking now at question number 20. Question 20 says, what is x when f of x is equal to 1/2, and to justify algebraically. In order for them to justify that algebraically, that means that we need to be working with our algebra skills in order to solve for what x is. So what I always try to have my students do is to tell me what the question is asking them. The question is asking, what is x when f of x or y is equal to 1/2? And so now I simply have to take those 5 functions that I dealt with previously, substitute in a 1/2 for my f of x, and then I'm only left with the variable x, and I can solve for x. Students should be familiar with how to solve equations with square roots and powers of 2, as well as working with the operations within a square root function, because we dealt with that previously in the Pythagorean theorem unit. Keeping in mind, you may need to remind students again of the plus or minus that goes along with when you square root a function. For our absolute value function, this solving may be something you need to remind students of. It is a skill that they learn in middle school, but one that they tend to easily forget. So you may want to help your students remember that after you substitute in for 1/2, you isolate that absolute value. And because that absolute value is measuring the distance from 0, then we know that it is either in the positive direction or it is in the negative direction, and therefore we are going to get 2 solutions, which is again why it has that V shape. For our final 3, these are a bit simpler, so depending on how you want to scaffold this within your groups, you may give these to students that you feel need to be successful and need to be able to contribute to the group. So here we know that f of x is 1/2, and I'm able to solve for x and get that x is 5 1/2. Here, when I substitute in 1/2 for f of x, I'm given that 1/2 is equal to 1, which we know is not true. There is no variable x here for me to solve, therefore that is a no solution. There will not be an instance where f of x is equal to 1/2. And finally, substituting in 1/2, distributing and solving, we are able to get that x is equal to 8. So we have multiple solutions depending on where we are in f of x, where f of x or our y value would in fact be equal to 1/2. Finally, we get to build slope into this as well. We are looking at determining the slope of each of those points on the graph of f of x. So what we're looking at here is when x is 3.5, 3.5, we need to know that y value, and we need to know what the slope is. So our students will need to refer back to our original graph and determine that when x is equal to 3.5, what is that y value? It's 2. What is the slope of that portion of the graph? It's 4. When we're looking at something like 6.213, I don't know exactly where that is, but it's a little bit more than 6, which puts me here. Every y value here between 6 and 7 is 1, and that slope is 0. When we're looking at -3, our y value will be 0. Here we do not have a slope because -3 is the beginning portion of that semicircle. There is no slope here because there is no defined function below or behind that -3 value. And then our remaining y values and slope functions. So I hope that you see that this is a great activity that spirals in several different points of information from geometry and algebra and middle school, and really allows our students to recall things that we're expecting them to be able to do in upcoming mathematics courses and keep all of that information that we're teaching them fresh.